there's the kind of intellectual answer, which is all of them would say, yes, like robots are the only way that my business is going to survive, but it's not viable for me. You know, I'm just Joe Schmo. I make chocolate chip cookies. I don't think I can do robots, right? Like I don't have engineers. I don't have technical talent. I don't have hundreds of thousands of dollars that I can put towards this problem. It's not viable for me. And so that was really where our work started, which is like, actually, we'll make something that does work for you. You know you need it. You know you don't have enough headcount to do the job, and we can make it easier.
Hey, Saman. Thanks a lot for joining me.
Thanks for having me, Brett.
Awesome. Well, maybe we can start off by you explaining what Formic does.
Yeah. So we're building a robot workforce for every factory in the world. We're starting with just America for now. And we build software that makes it easy to deploy robots. But in addition to the software, we actually build all the operating infrastructure to deploy and manage robots efficiently. And so we go to factories that are short-staffed, and every factory in America today is short-staffed, and we help them fill empty headcount with robots. So we're currently deployed in more than 100 factories. We make all kinds of products with our robots. We make tortillas for Chipotle and dog food and chocolate chip cookies and metal parts for aerospace and automotive and defense and plastic parts for lawnmowers and golf carts. Our robots are in those factories doing highly repetitive tasks, things that humans don't want to do. It's really helped these factories to kind of scale up and grow and become much more productive. It's helped the workers in those factories. It's improved worker retention significantly. And we see this as one of the critical things to building a world of abundance. You know, I think we are lucky to live in a society where we have access to all these incredible products, but the majority of the world doesn't. And if we can 100x the output of the world, robots really are the only way. And so we're really excited by the possibility of using robots to kind of solve all the mundane work and increase the overall output of humanity.
Yeah, that's awesome. And I guess, there's a lot of interesting threads there. And I think I recall talking a lot early on about how the robots are already there, and there's just like, I guess, future not evenly distributed was a big part of it. But maybe you can talk about your background and how you came to this problem and decided to work on it.
Yeah. So I was kind of an engineer by training. I worked as an engineer for some time. I built manufacturing facilities in China and in different places, and kind of always had this kind of intersection between technology and like the physical world of making things. Like for me, that was always really fascinating. And then after working for a bunch of different companies and building these manufacturing facilities, I ended up starting a software company. That was a lot of fun. And it was kind of a nights and weekend project that actually turned into a business. And I ultimately ended up selling that company. After that, I actually became a VC for a while. I joined the dark side, as it were. I helped, I was incubating a bunch of early stage companies, and I just loved it so much. It was like intellectually so stimulating and a lot of fun to kind of help people realize their ideas and turn these things from kind of concept to reality, especially at the early stages. It was really, really satisfying. And a lot of our investments were at this intersection between AI and the physical world. You know, we saw the AlexNet, paper come out, and we said, well, this is going to change everything. Computers can understand the world now, and once they can understand the world, they can make better decisions, and they can act on those decisions, and we can actually solve problems in all of these industries that were untouched by technology. And so that was the thesis, and we invested in a lot of great companies during that time. But in robotics in particular, I kept feeling disappointment because I would see these incredible demos and I felt like I was living in the future. I would go to labs at Berkeley and Stanford. I would look at our portfolio companies and they had all these things that were working and doing incredible work. And then you'd go to the real world and you go to factories and construction sites and farms and you'd say, why are no robots here? Like there's clearly some kind of big gap between getting the robot to do the job and actually making it easy to adopt at scale. And as I saw that gap over and over and over again, eventually I realized, like, if I don't go and solve this, I'm going to regret it for the rest of my life. So I left about 5 years ago my role in VC, and I started Formic, and very lucky to have Initialized support me from the very earliest days. And we started building the business. And so here we are, we've been in market with product for about 3 years, and we're already in more than 100 factories. Being able to solve what I saw as like all the friction around adoption in the real world was really the challenge. Like, I think a lot of roboticists that I meet still on a daily basis get overly excited by making the robot do a new trick, right? Like how do I make the robot do a backflip? Or how do I make the robot pick up any arbitrary item that shows up? Or how do I make the robot be generalizable across any form factor? And like those are really fun technical challenges to solve. Those are really fun engineering challenges to solve. But those are not the things that are preventing adoption in the real world. If you could solve one task well and make it easy for people to use, like there's so many people who need that. And that was what we set out to focus on. So we said everybody's focusing on the wrong problem of making the robot smarter. We need to focus on the problem of driving adoption at scale.
And like from the onset, like how much of that was actually even like an engineering problem? I remember digging into a lot of spreadsheets to start off when you were looking into this.
Yeah. So we started with a lot of spreadsheets because the first thing that we said is, okay, we need to basically take a lot of the risk off the table for the customer. And so we built a whole asset financing platform. And that allows us to basically deploy robots in a way that customers can actually adopt, by paying a monthly rate or hourly rate. And that was one of the first things we had to de-risk. And so we did that. And then we said, okay, all the technical things related to deploying robots, we'll start by just doing them manually with engineers, right? We have great engineering talent. Let's go and do all the manual configuration and programming and deployment and operations related to those robots. And that was how we validated demand. Because once we did that and customers said, yeah, this is great, this is exactly what I wanted, we realized that there's actually a segment there that this serves. Then we started really going and solving the engineering challenges next. Because this goes back to my time as a VC. I saw so many teams focus on solving hard engineering problems right out of the gate, only to realize afterwards that nobody wanted it.
Yeah.
So like, let's kind of reverse the order.
And you were kind of like, maybe correct me if I'm wrong, but like early on, you saw the inefficiency. You knew that the math penciled out in terms of like applying robots to the problems these manufacturers had, especially smaller manufacturers in the United States. But was it immediately obvious to them that they needed automation?
There's the kind of intellectual answer, which is all of them would say, yes, like robots are the only way that my business is going to survive. So we heard that all the time. But then there's the second question that always came up, which is, but it's not viable for me. I'm just Joe Schmo. I make chocolate chip cookies. I don't think I can do robots, right? Like I don't have engineers. I don't have technical talent. I don't have hundreds of thousands of dollars that I can put towards this problem. And it's not viable for me. And so that was really where our work started, which is like, actually, we'll make something that does work for you. You need it. You don't have enough headcount to do the job, and we can make it easier.
Cool. All right. And so you get to this point where you figured it out financially. You've proven the customer say it wants it if you can get it in place the way they want. And now I guess the shape of the problem is more like, how do we scale and automate this? Exactly. And so like, take me through your thinking there. How hard is that? Is this like just kind of standard workflow, or like what are the complexities in deploying a lot of robots in these legacy contexts?
Yeah, I think that this is what Peter Thiel calls like a complex coordination business, in the sense that I can't point to like a single technical innovation that we did that's like, this is so overwhelming that nobody could ever copy this. Right. Really what it is there are hundreds of paper cuts that prevented people from deploying robots. And basically what we realized is unless you solve all of them one by one, like you're not really going to drive adoption. So we went and solved everything. Really, like I would break it into 4 buckets. Right? One is, how do you know enough about the task that needs to be done? You need to gather a lot of data about the factory and the task that's currently being done manually. Yeah. Typically that used to traditionally come down to maybe 500 questions that you would ask and measure, like you'd have engineers that measure things in that factory for like weeks and weeks at a time. And so we said, okay, we can use software to actually automate all that stuff. And so now we, with software, within basically 10 minutes, we can gather all the data that we need about that factory. We do a LiDAR scan. We have a kind of automated questionnaire. We ingest data from their ERP. And within 10 minutes, we have all the information that we need to know what is the mission for the robot? Like, what does it actually need to do?
And this is like relevant in part because like the insight here is that like all these people are trying to make robots more general purpose, but if you just take purpose specific robots and understand the problem well enough, most problems in factories are highly repetitive.
Exactly. Yeah, that's right. I think general purpose robots is great in certain contexts, like in the home or other places. But in your factory, like what's coming down that production line is more or less set. It's going to be the same thing all day, every day. The problem is with a general purpose robot is you actually have to make a lot of compromises to make it general purpose, right? To make it small enough. And, in the case of a humanoid, you have to restrict yourself to having 2 arms and, a head, and it's like a certain height and there's a certain payload capacity. And what we want in a factory is superhuman performance, not human performance, right? So like, why not have 6 arms and go 300 miles an hour? And so to do that, you need these kind of custom tasks.
And it previously was a domain of like some sort of integrator
exactly.
that like was costly and they didn't know who to talk to. I'm just like,
and it was reinventing the wheel every single time.
Yeah.
It was reinventing the wheel every single time, which is really the part that we're trying to avoid. So the 4 parts, one was scoping the task. Number 2 was actually building the robot. And so this is again where historically lots of customization would come in, a bunch of people tinkering to get the robot to work. And we said, what if we could productize this and just say, hey, these are the 4 standard modules that are pre-designed and pre-built, and they just kind of clip together to become the robot work cell. And this is where I just kind of want to clarify a term robot, because I think it means different things to different people. A robot can be just the arm. In the case of like a humanoid, it's like the full system. In the case of manufacturing, generally, when we talk about a robot, it's a full work cell. So a full robot work cell includes generally between 200 to 500 components. That includes the arm, but includes a bunch of cameras and sensors and laser scanners and radars and pneumatics and end of arm tools and conveyors and fencing. Like, you need all this stuff. And so in that example, we said, okay, here are the standard modules that make up a work cell, and how can we easily be able to configure and select the right work cell. Then the third thing is actually deploying that work cell into the factory environment. Again, this used to be a place where people would spend manually hundreds of hours customizing the programming of that robot to do each specific job. And we said, maybe we can use software to remove all that complexity. And so we built software that generatively writes the robot program for that robot. The robot itself is running usually on a pretty deterministic loop, because like we talked about, it's doing the same thing over and over again. But we don't want to have an engineer sit there and write kind of the same program over and over again especially when you have a lot of variety, right? You might have 40 SKUs or 50 SKUs in a factory, and you want to be able to approach each of them correctly. So we generatively write the robot program, as well as the PLC program and some of the other stuff that goes in the work cell. And then the fourth thing that we built is actually on an ongoing basis. Once you've deployed that robot, you need to monitor it and manage it to get to the performance uptime. So in a factory environment, you need 99.9% uptime or more. And I think that's something that most roboticists don't appreciate, because to get to 99.9% uptime, you need like very, very battle-hardened components and operations. And so we have 24/7 monitoring, we have teleoperations that can log in and resolve issues. We have like intelligent error recovery, so that if like the robot, for example, drops an item, what is the right sequence of events to get back to a recoverable state without human intervention? And then how do you kind of stop the line accordingly? Because you're in a production line. So if the robot suddenly stops and the upstream part of the line is still producing, you end up with kind of an accumulation of a bunch of garbage. And so you have to ensure that it's kind of connected to the other parts of the production line correctly as well.
And you have to do this in like within the scope of the current people that work at that factory, being available as they are the available humans to intervene. Yeah.
We also have our own technicians that go on site as needed to like repair issues. But this is a place where software plays a huge role, because of the teleoperation stuff that we built, and also the automated error recovery tools that we built. We reduced the cost to operate a robot by like 80%. And so the net impact of all of this is that it's cheaper to deploy, cheaper to manage, and the overall cost of deploying a robot goes down pretty significantly, which means that it's much more accessible to many more people.
And how did you think about like especially in the first 2 steps, like constraining scope, because it seems like that might be hard to approach from an engineering perspective that you think through, because like on the one hand, there's the entire breadth of every manufacturing facility in the United States, which I'm sure is insane. Yeah. And then on the other is like, there's the robotics that's available to you. And then there's probably a subset of that is like easier for you to deal with and deploy relative, and so you probably get to pick on the continuum, like how complicated you want setup and yeah, I don't know.
Yeah, I think so. What we basically did is we did a survey initially of about 100 or so factories, and we said, okay, what are the most common tasks that happen? And we broke it down by task. And for each of those tasks, we said, okay, if we're going to resolve this with a robot, what is the expected ROI of that robot for us? What is the expected ROI of that robot for the customer? What is the expected redeployability of that robot? And what is the expected operating cost and maintenance cost of that robot? And we basically optimized for those 4 things. And a few tasks fell to the top of the list. And we said, those are the ones we're going to go after first, where it's common enough across a wide enough variety of customers. So one example, for example, that we do a lot of is palletizing. And the reason we chose that as one of our earlier tasks is it doesn't really matter what you make in your factory. At the end of the production line, somebody is taking that product and putting it onto a pallet. And so it's so common that everybody needs it. It's also, there's a huge ROI for the end customer because that's typically where a lot of workplace injuries occur. You can imagine, lower back injuries and rotator cuff injuries by kind of lifting heavy things over and over again for 24 hours a day. And then from a robot perspective, we knew it was a solvable task that we can get to 99.9% uptime with currently available hardware. And so that was one of the first ones that we attacked, and we went after a few other ones in a similar kind of fashion.
Did you was implementing things somewhat manually the first few times enough to understand all the corner cases, or did you actually how iterative was it to go scan a factory with computer vision and figure out how that maps to real world deployable robotics?
Yeah, I mean, it's a continuous process, right? So we're continuing to iterate now. Just to give a couple of data points, for a typical deployment that used to cost us $170,000 by doing it manually with all of the kind of off-the-shelf things, today we can do that same deployment for about $80,000. And I think we're on track to get that same number down to $50,000 for the exact same performance. And the uptime has increased significantly because we figured out, here are the common failure modes in this robot. Here are all the components that typically wear out pretty frequently, and how do we ensure that we can resolve against that? Or what are the most common types of errors that we encounter from the in-feed material, right? Because every robot has to encounter some amount of variability. Based on what we know about that, we can train machine learning models to detect those types of anomalies and then resolve them gracefully. And so each iteration basically does one of 4 things: it reduces deployment cost, increases uptime, reduces operating cost, or increases flexibility of the robot so that the robot can basically handle a wider variety of tasks.
Have you run it? Are there just pathological cases? Are there customers where you kind of go scan it and you're we can't?
Totally. Yeah. I mean, it's not even pathological. I mean, there's just, if it's highly specific to their use case, we might say no. We often say no to projects because they're out of scope. For example, we had a case recently where a customer was making, dog food, right? And picking up those bags of dog food and stacking them onto a pallet is really difficult for a variety of reasons. It's solvable ultimately, but there's some complexity, right? When you pick up that bag, oftentimes the bag will rip, and so you're okay, how do I have to figure out
which is a disaster in a lot of ways.
Yeah, exactly.
Suddenly, dog food everywhere,
and then once you stack these bags, right? If you stack them kind of in a slightly wrong order, then they start to slide off, and you have this pile of, it's just there's all this chaos, and you're well, if we put really a lot of energy towards this specific use case, we could go and solve it, but we kind of approach them sequentially. And so within each task, we say, what is the kind of core set of things that we do really, really well? What are the things that are just slightly outside of that? The ones that are slightly outside of that, we attack them manually using engineers, right? So we have a bunch of engineers that go after the slightly more custom projects with the intention of turning those into things that we can do repeatedly and productized over time. And that way we kind of just keep expanding the portfolio of what we can handle.
Yeah, that's really interesting because there's probably like there's some aspect there's nuance to places where humans apply more complexity than they seem to be, and things that seem simple. And I imagine like over time you gain intuition around like what the tasks are and like what the components are.
And I think like I'll admit that like I think our approach is orthogonal to what a lot of people in the kind of tech industry today are betting on, which is general purpose intelligence, general purpose robotics. I mean, that sounds really appealing, and I would like for that to be the reality. Unfortunately, I just don't, for most kind of manufacturing tasks, I just don't see a path to true generalizability. Like you just have to have custom hardware for the different types of tasks. Like your best bet is to just try to build hardware that has a big enough envelope that it's useful for enough people. But like the kind of robot that you need to pick up bags of dog food that are 50 pounds is just fundamentally very different than the kind of robot that you need to put like candy into a box, right? Where you're doing it at a very high rate. You just need different hardware.
Yeah. Well, there's also seems like there's this other kind of philosophical or higher level meta question where, you know, like if you've gotten really deep into building robots, like you're probably energized by how hard the problem is, right? Whereas you've specifically made this decision and created this context where, like how do we deliver value is the KPI, not like how hard of a problem can we solve, which is I don't know. I guess that's a very interesting part of engineering versus against like research.
Yeah. I mean, I think that I constantly have to hold back myself in kind of going after fun engineering challenges. I'm like, oh, it'd be so like that bag palletizing problem, right? Like, oh, we could totally figure that out, you know? And like a bunch of our engineers get together in a room and we're like, okay, if we just did this and if we just did that, we can solve it. And then we have to kind of hold back and say, okay, yes, we could, but we're going to spend 2 weeks solving this problem instead of helping 10 more factories with the problem that we already are solving really well. And I think that's a constant balance between allowing yourself to kind of scope creep a little bit in your business versus focusing on actually building a sustainable company. And sometimes those two things are aligned, but sometimes they're a little bit orthogonal.
Excuse me. Were there places where you got it wrong and you're like, no, we can do that, and then suddenly you're in a, you know,
I mean, all the time. I mean, I kind of throw us into those situations a little bit on purpose, once in a while, you know, I think as a CEO, what I've learned is it's important to inject a little bit of chaos into the company every once in a while. I think things that are outside of people's comfort zone require a little bit of a push, right? And so like we do sometimes have to go to customers and say, look, this is kind of new for us and we haven't demonstrated historically that we can do this successfully. You're going to be a little bit of a big guinea pig, which is, you know, for a factory, that's a really hard thing to hear because they're dependent on that production for their survival. And if you screw it up, like they're in big trouble. So the only thing I can say after that is, and I'm the CEO of the company and I will guarantee that I will commit the full resources of our entire team to ensuring that it doesn't go wrong. And that's something that like kind of only the CEO can do ultimately. So, you know, I regularly do that, right? Like I kind of push us a little bit outside of our comfort zone and say, this is new, but we're going to figure it out. But I just have to be careful to kind of bite off like bite-sized chunks.
Yeah. Do you any examples of a problem you maybe weren't sure you were going to get to the other side of and like team figured out?
Yes, many. One of the main ones I'll say was I kind of gave the mandate last year that we want to cut the cost of our deployments in half. Okay. And that was one of those things that everybody looked at and said, like, come on, like this is insane. Everybody's doing it at this price. We're already below everybody else, and you want to cut it in half from where we are today.
Yeah, and then it felt arbitrary to everyone. You're just like,
yeah, exactly. Yeah. Like, what do you mean half? You know? And ultimately, it was one of those things that this is also like a personal reflection as a CEO. I realized like for these kind of harder problems, maybe I'm just not a great CEO, but like I've found only one way to really make fast progress on very hard problems. And that's a daily 8 a.m. meeting. Just like everybody working on this. We're all getting together every single day at 8 a.m. and making sure that we're, you know, pushing the ball forward because when it's hard, people kind of default to doing the things that they know how to solve. And this is one of those things that people don't know how to solve. So we basically have a daily meeting on it, and we just picked apart every single component in there and figured out what can we remove, what can we disintermediate our suppliers, what can we do to kind of standardize components that used to be custom. And we did a bunch of different things, and we did it, and we cut it in more than half actually ultimately. And I think it was a big win. And then the next time I said that, people kind of were like, okay, yeah, we know how.
I mean, it kind of like, I feel like that is like a lesson in startups. Like if you don't pick, like you just have to pick something to go after that's ambitious and see what happens. Because if you undershoot your ambition, you're certainly going to undershoot your outcome.
Yeah, absolutely. And I think there's just a default human tendency to say, this is how everybody else does it, and this is how we've always done it, and that's probably the right way.
Yeah.
And I think you just have to really resist that and say, like, actually, it's probably not the best way.
Yeah. Well, I feel like there's a tension in your business specifically because you're like, from the outset, like we are grounded in the practical, and yet we're still doing startup-y hard things, right? And so I'm sure there probably is more art than you're letting on about, like communicating that nuance to your team.
Yeah. I mean, I think there's also a big clash of cultures in that, right? Because I think when you're talking about manufacturing, you're generally
like learning from existing system integrators.
We have to have people in the team that have, for example, built large automotive plants, right? Like one of the guys who built all the Tesla Model X and Model Y production lines is on our team. And, in the manufacturing and automotive industry, like you have very little tolerance for mistakes and tolerance for error. I think Tesla's an exception, but most automotive engineers are very, very resistant to taking a risk. And then we have our software guys, which are generally very different, and they're like, well, if it doesn't work, we'll try it again tomorrow.
But your customers that you're deploying to are like out of the old.
Yeah, exactly.
Model.
Yeah. And so we basically have to it is a constant tension internally between, we have to deliver the outcome. Like we can't tolerate a robot being down for a week. Like it's just not an option. At the same time, we have to try to do things in new ways. And so, we've developed a couple of internal approaches around staging and doing kind of iterative trials before we actually deploy something to a customer. That's probably a little more time consuming than your typical startup, but ultimately ensures that we can keep that 99% plus uptime performance.
How do you balance, when, again, being, I guess, as I phrase it, like grounded in the practical, how do you balance evaluating new robotics that might be available and integrating that into your system? And, like I imagine once there's a lot going on, you could be chasing everything, or, you could be only sticking to things that are very already proven in the field somewhere. Like how do you think about that?
Yeah, I think it's relatively easy for us right now because we already have a decent sized customer base. We have more than 100 factories that are using our robots. So we're right now only willing to evaluate things that we know our existing customers want. That's probably not the forever strategy, but right now we know if we solve this incremental task with maybe a slightly different kind of robot, half of our customers would want it tomorrow. And we have a lot of things like that on our list. So we're able to kind of focus our resources on those types of tasks. And then we generally trial it, in our own facilities for a while. And then once we get to a certain number of cycles of usage and we have confidence that it'll work, then we deploy it to a smaller group of customers. And then we also have like a regional approach. So because we have technicians in the areas where we have the highest density of customers, we will generally roll out our new products first to the places where we have a high density of customers and a high density of technicians support to catch any issues, and then slowly roll it out across a wider footprint.
Yeah, that makes a lot of sense.
Yeah, it's very operationally intensive, I think.
Yeah.
Compared to most like software startups, we have to think a lot more about just like logistics and operations. And yeah, I mean, I think it's a discipline that I've had to kind of develop since we started the company.
Do you end up being a customer for your own software? Do you have to like organize, like automate these things internally to get it to work at scale?
Yeah, actually, so about 90% of the software that we build is only used internally, because for the customer's perspective, they just want a robot that does the job. How you get there is kind of irrelevant to them. So we build a lot of software for internal use, so that we can deploy these robots faster and manage them and maintain them more efficiently.
Do you think that fundamentally changes anything about your software org or your engineers, or like?
Absolutely. Yeah. Way less fit and finish and polish. We also have kind of a mandate where almost everybody involved in the kind of deployment and maintenance process has some tie-in with our software team and is almost like a product manager. So if they're responsible for maintenance, they're responsible for maintenance, and they're responsible for defining what the maintenance software tools need to look like. If they're responsible for deployment, they're also responsible for defining what the software tools need to look like to help deployments go faster and quicker. And I think that dual role is really empowering for a lot of folks as well.
Yeah, that's also interesting too, because you think about, I feel like it's something we've experienced at the firm. You talk to places that they're trying to work on custom software, and like sometimes buy-in is a problem. Mm-hmm. But when it's like fundamental to the business that we have internal software and ever uses all the time, and just becomes the source of truth for everything you do, I imagine that I know A, everyone buys in, and B, it like eats back into the culture. Right? The culture is like a little set because you get to dictate the software that everyone uses all day, every day.
Yeah, we had that buy-in problem in the early days too, where we said, "Oh, this is a great idea. We should build this software for them." And to your point, adoption was abysmal. And then it wasn't until they were actually deeply involved in the development process that they really had buy-in to use it.
Okay, I guess kind of maybe, I don't know, perhaps obligatory these days, but I'm asking a lot of people just because I'm curious how it's changing engineering organizations. Like, well, what is AI usage and LM usage, either in as a component of your product, or like, what are your software engineers doing these days? Yeah,
we use vision language models a lot for various types of like scene understanding for our customers' facilities, or for looking for different kinds of errors or issues and things like that. So vision language models have been a very useful tool for us because it allows us to not have to dedicate a lot of engineering resources towards testing out new tools. So like we'll have a product manager who just builds and deploys a vision language model against a specific type of error that they're trying to detect, and we can do it pretty accurately.
And like you're training your own models, or
mostly no. In some cases now, for specific types of errors, we're training our own models as well. But I think the vast majority of them are just kind of off the shelf models. And then we use LLMs also for a lot of internal tools, and this includes like in finance. We automate almost all the contract review work now. For we use a lot of AI in the sales process across different parts of the stack, both in terms of gathering customer sentiment, updating deal status across different tools, even some of the customer conversations, like automating the process of generating different kinds of reporting dashboards for the customer. We're using AI in recruiting, actually. So we for certain types of technical roles, we found that building a standard evaluation, like a set of standard evaluation tools, was really helpful. And so we basically built in a standardized questionnaire that we ask people live.
Most of this is like things you're rolling internally based on using like LLM APIs. Okay.
Exactly. Yeah. And that allows, basically after the interview, it automatic. So one of the issues that we were solving for there is like some of our technical resources just didn't have time to interview at the volume that we needed, or when they were interviewing, they didn't have time to do the full technical interview in the way that we needed them to. And so we basically automated the process of like a bunch of Q&A, and then automated like a scorecard generation from each of the candidates, and then had the manager, like the hiring manager, look at that and then do follow-up questions. So we found like the quality of hires went up pretty significantly when we started doing that in the process. I personally use LLMs for a lot of different things, just kind of digesting information from across the business.
Are most people using it in their software writing workflow?
Yes, it depends on the category. So for the ones that are building kind of pure like software dashboards and monitoring tools and things like that, yes, quite a lot. We also have some of our engineers that do a lot of robotics software, so writing software for the PLC or for the robot itself, or interfacing with different sensors and things like that. For most of that, we haven't found the LLMs to be particularly helpful.
Yeah. Is it as much as mandated, or is it just organic?
It's organic. Yeah. What I do is we have all hands every 2 weeks, and generally we ask somebody to present one of the ways that they're using AI in each all hands. And so it just gives people a little bit of a taste of what it can do. Yeah,
that's something I guess across a lot of the companies I talk to, it's surprising how much an education piece there is with a lot of people, because it's like, it seems very easy to use, but going deep on learning how, it sort of changes your entire orientation.
Well, I think that there's a couple of issues. One is learning how. One of them is habit change, right? You're just like used to doing things a certain way. Another one that I found is a big issue is I tried it 3 months ago and it sucked. And so
how many cycles am I going to spend on this?
Yeah, it's clearly not good enough for this task. And a lot of the time, if you try it again 6 months later, it's actually good enough. And that it's hard to get people to kind of revisit their past assumptions.
I'm also just struck that what's interesting about your company is that as a software org, the mandate is make our lives easier, right? Yeah. That's kind of what the point is. Yeah. And so it's I guess I wouldn't have intuited it, but as soon as you started talking about it, the fact that the same thing happens with recruiting. Someone just builds software to fix things and make client efficiencies. That's kind of what we do here. Yeah. Which is probably an attitude more companies should adopt, but it's easier when that is also the core function of the software org.
Yeah, I mean, the interesting thing is it's gotten to a place now where you often don't even need a software engineer to build a lot of these internal tools, so that's been a huge boost to productivity, because you only have so many software engineers. We want to stick them on the hard problems and then let people build their own tools for other things.
Yeah, I mean, literally, we were down there a second ago sitting at the table, and I was talking to our head of community Viv, and I'm like, you don't have access to our GitHub. What's going on? We have to fix this right now.
Yeah.
Cool. Well, this has been really, really fascinating. What should we look forward to from Formic?
Yeah, I mean, I think our focus right now is just having more robots do more tasks in more factories. And we're just continuing to turn the crank on getting better every single day.
Awesome.
Yeah.
Well, thanks so much for joining me.
Thanks so much for having me. This was awesome.